Breaking news. At 0156 UTC this morning, automated alert systems across the global astronomy network triggered at once. Within seconds, data streams from space-based observatories and ground stations began flashing red. In control rooms from Pasadena to Darmstadt to Santiago, scientists watched the same impossible pattern unfold in real time. Today, the impossible just happened. Moments ago, a fresh wave of telemetry from the interstellar object known as 3I Atlas revealed a cascade of anomalies so severe that agencies initiated an emergency scientific conference within the hour. This was not a routine update. This was not a calibration error. What appeared on the screens defied every predictive model we have. An object we believe to be cold, inert, and predictable is now behaving with precision. This changes everything we thought we knew. If you want real-time updates on the most mysterious cosmic events ever recorded, make sure to like, subscribe, and stay with us, because what you're about to hear is not speculation. It is data, and it is unprecedented. The confirmation did not come from a single telescope or a lone analyst staring too long at a noisy screen. It came from convergence. NASA's Deep Space Network detected the first discrepancy during a routine orbital refinement. Minutes later, ESA's European Space Network confirmed correlated deviations in radar echo timing. Almost simultaneously, optical observatories in northern Chile reported a subtle but measurable change in reflected light from 3I Atlas. At the Atacama Large Millimeter Array, technicians halted scheduled observations and pivoted all dishes toward the target. At Harvard's Center for Astrophysics, graduate students were instructed to freeze simulations mid-run. At Caltech's Jet Propulsion Laboratory, senior scientists were pulled into emergency briefings before sunrise. The James Webb Space Telescope, operating in infrared bands between 0.6 and 5 microns, was quietly retasked. Hubble followed, cross-checking visible light albedo changes. Radio arrays in South Africa and Western Australia joined in, searching for correlated electromagnetic disturbances. This was not one instrument malfunctioning. This was consensus. For the first time since its discovery, 3I Atlas was no longer behaving like a passive interstellar visitor. 48 hours before the alert, everything appeared deceptively normal. Orbital solutions showed a clean hyperbolic trajectory. Velocity relative to the Sun remained steady at approximately 42.7 kilometers per second. The object was inbound at 1.64 astronomical units, its modeled surface temperature hovering near 135 Kelvin. Spectroscopy showed a composition consistent with carbonaceous material and water ice with trace silicates. No jets, no rotational instability, no warning. Then, 36 hours before the alert, tracking stations in Goldstone registered a minor but statistically significant deviation in acceleration, just 0.04 millimeters per second squared. Insignificant on its own, but when Madrid and Canberra confirmed the same anomaly, analysts paused. There was no corresponding outgassing force. Solar radiation pressure could not account for it. 24 hours later, thermal imaging from Atacama revealed uneven heating across the object's surface. Instead of the expected gradient, hotter on the sunward side, colder on the trailing edge, the distribution appeared segmented. Some regions cooled while adjacent areas warmed, fluctuating by as much as 18 Kelvin in minutes. No known passive process could produce such controlled thermal variance in deep space. 11 hours before the emergency alert, rotational data revealed something even stranger. 3I Atlas had been tumbling chaotically since detection. Now, abruptly, its rotation rate slowed by nearly 7% and aligned along a single axis. Angular momentum appeared to dissipate without any measurable energy loss. I remember staring at the incoming plots as the realization set in. The curves were too smooth. 2 hours later, ultraviolet spectroscopy detected a faint but persistent emission line at 121.6 nanometers, hydrogen Lyman alpha, pulsing at regular intervals, every 19.4 minutes. The intensity was low, but the regularity was unmistakable. Then came the moment that forced agencies into emergency mode. At 0156 UTC, high-resolution interferometric imaging resolved a sudden structural change. The silhouette of 3I Atlas, previously elongated with an aspect ratio near 4.8 to 1, began compressing along its major axis. Over the course of 29 minutes, its profile transitioned toward a more symmetrical configuration. Not spherical, not random, precise. The change amounted to a 12% reduction in length and a corresponding expansion in width. Total volume remained constant. Mass estimates, derived from gravitational perturbations on surrounding dust, did not change. No natural process could produce such symmetry on that timescale. Within minutes, emergency calls were placed. Dr. Elena Moravec at ESA's Space Situational Awareness Program initiated a cross-agency verification protocol. Dr. Jonathan Reyes at Caltech ordered immediate N-body simulations to test whether tidal forces or solar radiation pressure could be responsible. They were not. 3 hours after the shape change, radio telescopes detected a faint broadband emission between 1.4 and 1.6 gigahertz. Not a message, not narrowband, but structured oscillations repeating with mathematical precision. Analysts soon noticed something else: prime number spacing. Intervals of 2, then 3, then 5, then 7 minutes appeared embedded in the modulation pattern. This was no longer random. This was responding. At MIT, gravitational modeling ruled out internal collapse. At the Max Planck Institute, material physicists confirmed that no known ice-rock composite could reconfigure itself without catastrophic fracture. At Stanford, machine learning classifiers trained on millions of known celestial objects returned a null result. No analog, no precedent. 2 hypotheses began to crystallize in closed-door meetings. The first, the mainstream explanation, proposed that 3I Atlas might be composed of an exotic anisotropic material formed in extreme interstellar environments. Under solar heating and tidal stress, internal phase transitions could account for controlled deformation and anomalous emissions. Proponents pointed to the unknowns of interstellar chemistry, to physics not yet catalogued. But the second hypothesis was far more unsettling. It suggested that the object was not passive, that the observed changes were controlled, intentional, technological, or the manifestation of physics far beyond our current understanding. Dr. Marcus Hale of Harvard reportedly said during a private briefing, "If this were occurring in a laboratory, we would call it active matter." Then came the second wave. 17 hours after the initial transformation, a minor surface feature, previously identified as a shallow protrusion, simply vanished. Not detached, not sublimated, it disappeared across optical, infrared, radio, and radar bands simultaneously. No debris, no plume, no energy spike. The remaining structure adjusted within minutes, redistributing mass to maintain balance. Relative symmetry was restored to within 0.02%. At the same time, magnetometers aboard Earth-orbiting satellites registered a localized disturbance, a fluctuation of 0.3 nanotesla, synchronized precisely with the object's pulse interval. Minor, harmless, but unprecedented. Inside mission control rooms, the atmosphere shifted from curiosity to silence. Encrypted channels lit up, data access was restricted, analysts noticed delays in public releases. World governments were briefed, not on conclusions, but on uncertainty. Subtle effects followed. A cluster of low Earth orbit satellites experienced transient communication dropouts. Radio blackouts flickered over parts of the South Pacific. Navigation systems reported timing errors measured in nanoseconds. Migratory bird tracking data showed deviations of several degrees from expected paths, coinciding with geomagnetic anomalies. No one announced panic, but no one slept. As the hours passed, emissions from 3I Atlas began to stabilize. Pulses aligned, thermal output converged toward equilibrium. The object settled into its new configuration, a smooth, faceted form exhibiting rotational symmetry to within 0.01%. It was no longer behaving like debris. It was behaving like a system. Teams rushed to understand what they were seeing. At Caltech, supercomputers ran trillions of iterations, modeling gravitational perturbations and internal stress responses. At ESA, spectroscopy experts examined spectral bands from ultraviolet through mid-infrared, searching for chemical signatures that might explain the transformation. At NASA, analysts compared the data against every known class of comet, asteroid, and interstellar body. Nothing fit. The emergency conference was announced quietly, then confirmed publicly. Representatives from NASA, ESA, Harvard, Caltech, and multiple international observatories would convene within hours, not to present answers, to confront questions. I remember staring at the live data feed as the final packets arrived before dawn. The graphs were calm, the equations balanced, and yet nothing about them felt reassuring, because for the first time we were not just observing an object behaving strangely, we were witnessing behavior. In the quiet moments that followed, reflection replaced urgency. For centuries, we believed the universe was indifferent, a vast stage of matter and energy following immutable laws. But what if some of those laws include agency? What if intelligence in some form is not rare, but simply subtle? Maybe we are not witnessing the end of certainty. Maybe we are witnessing an invitation. As 3I Atlas continues its silent passage through our solar system, instruments remain locked on target. Every pulse is logged, every fluctuation analyzed, every deviation from expectation archived in real time. The data keeps coming, the questions keep growing, and one thought refuses to fade. What happens when it changes again? Subscribe to follow the next update because the story of 3I Atlas is far from over.